times the u dx. And that implies the y dx is 1 all over 2u raised to the power half times the u dx is 3. So I can write that as what? As 3 all over 2u raised to the power of half. Do we stop there? No. U is a strange thing. The function we had was y equals to what? The root of 3x plus 7. We had no u there. Therefore, we have to replace this u as what? 3x plus 7. So we say the y dx is 3 divided by 2. 3x plus 7 comes in there. Raised to the power of what? 1 over 2. So I have there 3x plus 7. So you put a look on that again. After which we take question B. So we're looking at the second question, that's B. Here we have y is equal to 1 all over 6x minus 11 all raised to the power 7. Do not be scared. What do? Take the denominator upward and we have it as what? From the rule of indices, this simply becomes minus 7. That's it. And then I deposit my 6x minus 11. Again, we can see this is what? A function of a function. We have an outer function, an exponential function raised to the power minus 7, and then we have an linear function, the linear function there, 6x minus 11. Again, I go through the same process. Let me use something else. Let's not assume it must always be u. Let's say let p equal to 6x minus 11. It's not compulsory, we must always use u. Let p equal to 6x minus 11. Then my y will be what? Will be p raised to the power of minus 7. P replacing 6x minus 11. Again, we know that our dy dx will be what? Our dy dx will be equal to what? Will be dy dp in this case. We are not using u. Dy dp times the p dx. That's our guiding rule. So first I look for dy dp. I say, okay, my y is equal to p raised to the power minus 7. What is dy dp? The y dp will therefore be what? Minus 7 times 1 as usual. Just following the rule. That gives us minus 7. P. Subtract 1 from minus 7. Minus 7 minus 1 gives us minus 8. So that's it for the y dp. How about the p dx? And I ask, what is p? Oh, p is equal to 6x minus 11. Therefore, the p dx will give us, differentiate 6x, we all know this, that is 6. We differentiate 11, that's a constant, so we have 0. So we have the y dp, and then we have the p dx. Remember the rule says what? The y dx is equal to the y dp times the p dx. So I'm looking for what? The y dx. It should be what? The y dp, which is minus 7 p raised to the power minus 8. That's this line. Times the p dx. The p dx is 6. I say, okay, the p dx, 6, the y dp, minus 7 p raised to the power minus 8. 6 times minus 7 gives me minus 42. Then we have the p raised to the power minus 8. We can now replace our p. P is what? 6x minus 11. So I replace p, and I have minus 42. That's my p raised to the power minus 8. 6x minus 11. We quickly take c. That's c. Y is equal to 1 all over square root of 5x plus 2. Again, this should not scare us. First and foremost, we throw the square root sign away by putting this bracket raised to power 1 over 2. That's all. The square root sign has gone to rest. And then next we move this upward, and what will happen? The exponent will simply change its sign. So I have this as 5x plus 2 raised to the power of minus half. All these are just rule of indices. Your indices is not very good. Please go and get the CD for indices and logarithms. This is our what? A composite function. Function of a function. So we apply the rule again. Let's bring our popular u back into the system. U is equal to 5x plus 2. What else? Y is equal to, therefore, in place of this I have u raised to the power minus half. So okay, let me get my dy du. Because I know my dy dx will be what? Dy du times du dx. So there's no need repeating all those anymore. Let's go straight and get our dy du. Dy du should be what? Minus half times 1. That gives me minus half. Subtract 1 from minus half. That gives us what? Minus 1.5, which is minus 3 over 2. So I have u raised to the power of minus 3 over 2. I take that again. I'm differentiating y equals to u raised to the power minus half. The rule says multiply this by the coefficient. Minus half times 1 gives me minus half. Now subtract 1 from the exponent. Minus half minus 1. That's minus 1.5, which is minus 3 over 2. Okay, that's it for the y du. You may want to rearrange this and take, because of the minus sign, you bring it downward again, following the rule of indices. Because of this minus, I write 1 all over u raised to the power 3 over 2. Oh, here I have minus half. The minus will be there. 1 over 2, I can keep the 2 downstairs. So that's it for the y du. How about my dy du dx? Our u is 5x plus 2. Remember? U is 5x plus 2. Of course, the u dx should not be difficult to obtain. The u dx is what? Is 5. We should all be professors by now. We're looking for the y dx. The y dx is what? The y du times the u dx. The y du times the u dx. What's the y du? The y du is there. So it is minus 1 all over what? 2 u raised to the power 3 over 2. And what are the u dx? The u dx is 5. So multiply by 5. That gives us minus 5. That's 5 times minus 1. All divided by 2 u raised to the power 3 over 2. And if we substitute our u back, we have minus 5 all divided by 2. In place of u, I have this 3 over 2. What's our u? Our u is 5x plus 2. So I have there 5x plus 2. That's it for function with function. But stay back. I'll show us how to obtain all what we've solved so far in just 2 lines. Now, for the purpose of the UME exam, where time is of essence and your working is not expected, it is important if you can have a faster means of differentiating a function of a function, rather than going through the tedious process of substituting this with u and going through your dy du, du dx. Let's look at this. I want to differentiate the same function we had earlier on, dy dx. I'll just have 2 parts to it. My first part, I'll break this into two parts. I say, okay, let me look at an outer function as if I'm closing this up. And I just look at this alone. And differentiate the outer function and say 10 times 1. 10 times 1. And I have a 10 there. And subtract 1 from 10 and I have 9. So I have differentiated the outer function. And then now, I can now look inward. So what is inside? Oh, what I can see inside is what? 2x minus 5. Now let me differentiate 2x minus 5. I differentiate 2x minus 5, it gives me 2. And I multiply with that 2. Now I can say, oh, what was here? This was 2x minus 5. And I simply say therefore 2 times 10, that's 20, into 2x minus 5 raised to the power 9. In just 2 lines. I'm sure we are happy with that. I'll take another example. This was our second question. Let's use the same methodology to see if we can differentiate this without going through the long process. Again, the y, the x. I'll be looking at 2 parts again. But first and foremost, I have to deal with the square root sign. And this will become 3x plus 7 raised to the power of what? Half. That's okay. I look at the outer function. And let me differentiate the outer function. Half times 1 at the back here there. Half times 1 will give me half. I subtract 1 from the half there. It gives me minus half. Therefore, I have differentiated the outer function. I move inward now. Oh, the inner function says 3x plus 7. Differentiate 3x plus 7. And I have 3. I say therefore, 3 times half, that gives me 3. Whatever is there is still waiting. All divided by what? 2. Okay. What's here? That's 3x plus 7. If you like, you can take this down. Or you leave it that way. If you take it down, we have 3 standing upstairs alone. 3x plus 7 raised to the power of half comes down. And then we have the 2 standing there. So that's 3x plus 7. Take note, I just split this into 2 parts. Outermost function, innermost function. Differentiate the outermost function first and keep it there. Differentiate the innermost function, multiply the 2. So this is actually my dy du and this is my du dx. One more. First, before I do that magic to this, what do? First and foremost, use your indices and simplify this. We have this as 5x plus 2 raised to the power of half. And this is the same thing as what? 5x plus 2 raised to the power of minus half. So we start off from here. Y is equal to 5x plus 2 raised to the power of minus half. Identify the outermost function. The y dx. The outermost function is the exponential function. So I differentiate that first. Minus half. There's 1 there. Minus half times 1 gives me minus half. Subtract 1 from minus half. I have minus 1.5, which is minus 3 over 2. Okay. I've differentiated the outermost function. How about the inner function? 5x plus 2. Differentiate 5x plus 2. I have 5. So I have 5 times this. That gives me minus 5 over 2. Meanwhile, you can drop this back. 5x plus 2. Because of the minus sign, let me take it downstairs. So I have there 5x plus 2 all raised to the power of 3 over 2. And stop. So that's it for function of a function. Next we look at the product rule. For the product rule, we have a function such as we have 2 functions that are multiplying themselves. That's where you get the word product. So the product rule. Let's say I have 2x minus 5, 6x plus 1. and I want to differentiate this. Of course, you will say, this is very simple, let's just expand. That's true. But what if we had something like this there? Would that be still simple? No. So let's first and foremost use a very simple form of it and obtain a rule for handling products. When we have two parts in an expression that want to differentiate, multiplying themselves, we say, let one part be u and let the other part v. So let v be equal to 6x plus 1 and let u be equal to what? 2x minus 5. And the rule says this, that if y is equal to u times v, where u is 2x minus 5 and v is 6x plus 1, the rule simply states that what? Since y equals to uv, that the y dx will be u dv dx plus v du dx. What does this imply? It means differentiate v, multiply it by u. Then differentiate u, that's 2x minus 5, and multiply it by v. Add the two parts, and that gives you dy dx. In a very simplified form, this can be written as dy dx as u dv. Instead of dv dx, we just say u dv plus v du. So we apply this rule in solving this question right away. So we apply this in solving y equals 2x minus 5 multiplied 6x plus 1. Let's differentiate that quickly. Here we have y is equal to 2x minus 5 by 6x plus 1. We have a product here. So say let u be this, let u be 2x minus 5, and let v be 6x plus 1. So if I use the 2x minus 5, v is equal to 6x plus 1. Remember the rule, we need to know the u dx, which I can just write as du, but for now, let's put the u dx. Subsequently, I'll just go straight for du. The u dx, differentiating 2x minus 5 will give us 2. Of course, it's a constant. That becomes 0. I differentiate here the v dx. Differentiating this, we have 6. Remember our rule, the y dx, when you have a product, y equals to u times v, will give us what? U dv dx plus v du dx. As I said, I can write it as u dv plus v du. What's my u? 2x minus 5. So I have 2x minus 5 times the v dx. The v dx is 6 plus our v is what? 6x plus 1. So we have 6x plus 1 times the u dx. Our du dx is 2. Well, this is a very simple one, so we can easily what? Expand. Expanding this, I have 12x minus 30. That's 6 times 2x, and 6 times 5. Plus 2 times 6x gives me 12x plus 2. Now combining 12 to 12, I have 24x minus 30 plus 2 gives us minus 28. And that's it. The y dx. So a very straightforward one. Immediately I'll take a second example. I'm sure you have a very better look of this. I'm moving straight to look at what I have on this side. Differentiate with respect to x. 5x minus 3 multiplying x squared minus 2. Almost the same thing as we had before. 5x minus 3 by x squared minus 2. Of course, we can identify a product here. We have 1 u, this as v. So I can say my u is equal to what? 5x minus 3, and my v is equal to x squared minus 2. What do I do next? I take my du dx, and I take my dv dx. If I say u is equal to 5x minus 3, and v is equal to x squared minus 2, of course, we can say that our y is therefore what? u, v. That's u, and that is v. Straight up, I get du dx. The u dx from here gives us 5. And the v dx, you agree with me, that's differentiating v used to give us 2x. Of course, this is a constant that one travels. And then to conclude, we have that dy dx is what? U dv plus v du. By dv I mean dv dx, and by du I mean du dx. What's my u? U is 5x minus 3. And what about dv? Dv is our dv dx, and that's 2x plus v is x squared minus 2. And then du, which is what? Du dx is equal to 5. Of course, that's it for dy dx. Just do some simplification. 2x times 5x. We have 2x times 5x will give us 10x squared. Then we have minus 6x. 5 times this, as a plus there, plus 5x squared. And then minus 10. Finally, dy dx will give us 10x squared plus 5x squared, that's 15x squared minus 6x minus 10. And that's it for dy dx. We'll take 3 more examples to emphasize more on what? On the product rule. Take a closer look on this. We have our last 3 examples considering product rule. Right here I have y equals to x cubed multiplying 2x plus 1 all raised to the power 5. We have to differentiate that expression. Y is equal to x cubed 2x plus 1 raised to the power 5. We should be able to identify that this is a product. Why do I say this is a product? I have one part here. This is my u, and that's my v, a left and a right part. Of course, you can see that our v is a function of a function. But that notwithstanding, we have a left part and a right part multiplying. So I call this my u, and I call the whole of this part my v. So I'll say u is equal to x cubed, and v is equal to 2x plus 1 raised to the power of 5. Please take note, I'm not saying my v is just 2x plus 1, but 2x plus 1 raised to the power of 5. That way I can say that y is equal to